Have you ever wondered about the invisible architect shaping our planet's mountains, valleys, and coastlines? It is a constant, universal force that plays a starring role in sculpting the very ground beneath our feet, influencing everything from the slow creep of soil to dramatic landslides. Gravity is the fundamental force responsible for sediment movement by consistently pulling all material, including loose rock and soil particles, downslope or downstream. It acts as the primary engine, driving the relocation of Earth materials from higher elevations to lower ones, whether directly or through intermediary agents. The underlying mechanism is straightforward yet powerful. Every particle on Earth possesses potential energy due to its position relative to the planet's center. Gravity continuously works to convert this potential energy into kinetic energy, initiating motion. When the gravitational pull on a sediment particle, or a mass of particles, exceeds the forces resisting its movement, such as friction or the cohesion between grains, movement occurs. This can happen on steep slopes where the angle of repose, which is the steepest angle at which a sloping surface formed of loose material is stable, is exceeded, or in water where buoyant forces reduce friction and allow gravity to move particles more easily. Understanding this fundamental principle allows us to predict and interpret many geological phenomena. For instance, in fluvial systems, gravity provides the energy for rivers to flow, carrying vast quantities of sediment from their headwaters to the sea. Similarly, glacial ice, itself a powerful erosional agent, moves downslope under the relentless influence of gravity, transporting embedded sediments and carving out U-shaped valleys. Recognizing these gravity-driven processes is crucial for assessing land stability, designing infrastructure, and understanding landscape evolution. A fascinating insight lies in the concept of mass wasting, an umbrella term for processes where gravity directly causes soil and rock to move down a slope. This includes events like rockfalls, where individual pieces detach and tumble freely, and more complex movements such as slumps or earth flows, which involve a combination of sliding and flowing. The critical factor is often the presence of water, which saturates the ground, increasing its weight and reducing the internal friction between particles, thereby making it easier for gravity to overcome resistance and trigger movement. Ultimately, gravity is the persistent, omnipresent force that ensures Earth's surface is in a constant state of flux and rearrangement. By pulling sediments downwards, it shapes our landscapes, from the grand scale of mountain ranges slowly eroding to the subtle deposition of silt in river deltas, continuously remaking the world we inhabit and demonstrating geology's dynamic nature.